Hey, everyone. So it's my pleasure to introduce Rajesh, who's going to talk about Puppet on a CI environment. He works at Here, the company Here, not actually right here. And without any further ado.
Hi. Thank you. I hope most of you guys can actually see me. And yeah, I hope we can do this fast so we can break for lunch very soon. And yeah, I work for Here. We make maps for Android, Windows Phone, and it's coming to iOS. And it's free, so try it out if you don't have it already. And I work as a developer support engineer for certain components that go into that product. And we have been working on Puppet for almost 1.5 years. And the CA infrastructure that we have is mostly on VMware, and we use Jenkins a lot, and Puppet to do the configuration changes, and all that goes into it. So, okay. Can you hear me? Here? Yeah. Is it okay now? Okay. So, yeah, that's mostly what we have in our environment, and that coffee mug is not Java, it's actual coffee. It contributes a lot to the work. So, and yeah, I would like to present this as a kind of story that what I went through. I joined and then I selected Puppet and went through this whole lot of effort to manage it and where we are now, and then what are we looking at going forward. Yeah, and yeah, so when I joined, our team had a couple of virtual machines and about 50 of them, and they had this lab where we test all this code after continuous build is happening. And they used to have this kind of strange maintenance Wednesdays. So they used to have virtual machines defined as templates, and they have these changes going in, and then they would just delete all the VMs and reclone on Wednesdays. So, a couple of hours, the whole thing is down, and people were kind of, why it is down, can't we find a better way, and all that. And then we came up with this plan that we'll have a Puppet master and agents going into each node, and then we can have this delta changes that is coming from the developers. So they're always in a hurry that they want to introduce a new library, or they want to introduce a new version of, let's say, the compiler. So they always want it like very fast, and so Puppet really helps in that, managing those changes going into the nodes very quickly. And we also introduced Nagios to monitor our nodes so that they, basic stuff like don't run out of disk space or check the CPU load and things like that. And of course, the initial struggle was to get the agents on all the existing nodes and also into the templates. So for the existing nodes, we already had them connected to Jenkins, luckily, so we used Jenkins itself to push the agent. And then once they are reporting to the Puppet master, then we started to push things through them. And we also got our templates updated with the Puppet agent, so it's baked in kind of. And that way, a less effort goes into when the provisioning happens for the new nodes. So essentially, we got rid of this maintenance Wednesday breaks. Yeah, so that's kind of things we handle with Puppet. So, and always supporting developers you will hear it a lot that they want it all yesterday. So when a request comes to you, it's always like, oh, I started using that on my laptop and it works. So now I want it on all machines. So, so that's how it usually goes. So we started with general system config things, packages, and their configuration files, SSH keys, bot accounts, and then we have our Git repos, so those keys, and then cron jobs, mount points. We use Windows, not a surprise. So we have our product supporting Windows fonts also. So registry entries, a lot goes there, and a package repository for the CentOS and Ubuntu machines we use. So we kind of started thinking how we can standardize. I mean, it was a lot of spaghetti code later. We were in a hurry to get this implemented and get going. So we didn't really think about how it can be done in a very quality way. Most of the time, the thumb rule was that it's working, so let's keep it that way. And so then we started thinking about how we can improve this and stop going through a lot of code that is with arrows and things like that. So then we started looking at modules. Yeah, so before going into modules, we also set up the dashboard. So we are still using ENC for our modules, classes, and we group systems according to the project. So each project has different requirements, so then we can easily attach what they need to their group of machines in the ENC. And we also looked at Forge. Of course, the first one we pulled was MOTD to see how it was, and then we started writing our own things to support our own environment. Then slowly we grew into that kind of things like Artifactory, Kubernetes, Jenkins, Git, and all that things. And I would say it's still at a beginner level, but it's a lot there now. After a couple of months, we have been doing this, and I say it's in a good shape. So now the next thing we wanted was to test it out before we just write this and push it to the Puppet Master. So we thought about using what we have, the CI. So we started using Jenkins itself to test our Puppet code. So we use Docker for creating instances of Ubuntu 12 and 14 and CentOS. So we get a clean environment every time, and we run. We have a QA Puppet master itself. So this, whenever we make a new commit to our Puppet code, it goes to the QA master first, and then these Docker instances are spawned, and they do a full run as if a production node will do. And we get the feedback in a couple of minutes, and then we also have these kind of jobs for validate, lint, and then test, and then it goes to the Puppet master. So all this is chained, different jobs in Jenkins. So we actually get quick feedback, and we also, these jobs act as different gates. So any stage it fails, it doesn't go to the master. So we can be kind of assured that it doesn't screw up heavily. So and the test is the test run is the actual one that takes most of the time. So if there is something else failing, we will be knowing it within seconds. So that's how it is. And now we are looking at, by this time, this is almost a year into the efforts, and now we are looking at more collaboration coming. We are extending our this infrastructure within our company to other groups if they want to kind of collaborate and do things. We already have a few people interested, and they are trying to contribute to this. So it's kind of still going to grow. we already have about 500 plus nodes, and we also wanted developers to get these changes done very quickly, so we configured our agents to run at 10 minutes intervals, which created a hell of a lot of load on the Puppet Master, so things started going a little slow. So then we looked at how we can optimize. So basically we looked at how we can optimize the MySQL for the dashboard, and then we configured log rotations. We don't keep anything older than 2 days, so we just keep rotating all the logs, and we run those prune, optimize, those kind of things. And we looked at RAM and CPU of this machine that is running. It's a virtual machine, so we could easily, tweak it. Then we also thought about running the dashboard itself in a separate host so that this load can be split. And yeah, so it's kind of good now for that kind of load. And we are now looking at, with this collaboration effort coming from different parts of the organization, we are now looking at having support for thousands of nodes. We are looking at having even our nodes distributed across data centers in the company. So then we are looking at how we can do that. So we are thinking about introducing PuppetDB, using Foreman to centralize all these different data centers, using Hera, and R10K is in the plan. Also, with collaboration, we would like to do some code review, things like Gerrit or something else. Of course, that means more coffee. So, yeah, that's all about this story. So, thank you. You can reach me there, and we got like some time for questions. Thank you. Thank you. The Docker containers itself, they act as a client to the master, the QA Puppet Master. So before the code actually goes to the production Puppet Master, this Docker instance does a full run against the QA Puppet Master, what change we just committed. So we know that our production machines don't break. So it runs as it is, a server and an agent. So we are reproducing the actual environment.
So it's the Puppet run itself is free. It's okay, or what?
We bring up this Docker instance and we run Puppet agent -t against the QA Puppet Master, where the latest code is checked out, and that runs through all the changes that would happen in a production machine. So if it fails, then the job fails. It doesn't push the code to Puppet Master. It fails with an error that it couldn't apply a resource, for example.
Okay, so if Puppet run itself works, you deploy it to production.
Yeah, if Docker container Puppet run succeeds, then the next step is triggered. So that is another push to the deployment. So it goes to the production master.
Other questions? Oh, there's one.
Yeah. Lint. Yeah. We run a Git checkout in one of the Docker containers, and we run Puppet lint against the init pp. So I don't have that code snippet, but I can share it. But the lint actually helps you to understand how well your code is written and if there are serious errors. So we run essentially a find all init.pps and run lint against it, and then it will tell you if there is an error or a warning. And then we have our Jenkins job checking the log itself for the Puppet lint for error or a warning keyword. And if there is an error keyword found, it fails the job. So, and the push stops right there. And that's before lint, we run the Puppet parser validate. So we know that there is no severe syntax problems. And then the lint. Both of this takes under a minute. It's very quick. So yeah. Yeah. Whatever comes to my hand. So I use, sometimes I use VI, sometimes I use some text editor. I don't really restrict myself to something.
Oh,
Sorry? Okay. So what did you miss?
so we have a
Sure.
question in the back over there, I think.
Yeah, hi. Yeah. I didn't get you. Yeah, the Jenkins jobs are created separately. They are not run by Puppet, but it keeps a polling on our Git repo so that whenever somebody commits a change, it triggers on itself. So if you don't get a mail back from Jenkins, that means it's in production. And something fails, you get a mail. We do it on the Git repo. So the Jenkins monitors our Git repo. And then it triggers the whole chain of validating. Hi. No, right now the Jenkins job definitions are manually created and maintained. Yeah, yeah, yeah. We could automate it using DSL or something, but right now it's just manually managed. We don't create a Jenkins instance for testing this. We have a Jenkins instance that's running all the time. So it's only creating the QA instance and Docker images that will run against the QA instance. So Jenkins always stays. Yeah.
Just as information, there's a wonderful Jenkins module that allows you to rebuild the Jenkins from scratch, including your own saved project.
Yeah, we run this inside our data center, so it doesn't really, we don't pay for keeping it on all the time. Yeah, of course we can create a Jenkins on the fly, but then that would just add to the whole execution time. So we thought of keeping the Jenkins on all the time and just have Docker instances doing the job. Yeah.
Excellent.
Yeah.
Thank you so much.
Thank you.